Good morning, good afternoon, and good evening. Welcome back to the Spring Webinar Program. I'm your host, as always, Peter Humphrey, today I am very pleased to bring Michael Plöd from InnoQ back to you once again for his next installment in our domain-driven design series. Today we'll be tackling some cool stuff, the internal building blocks that we're going to be tackling on aggregates, entities, and value objects. So Michael, excited to have you back this morning. We're all primed and ready to watch videos after Spring 1. I think everyone's going to be binge watching from the event. So we'll be able to add your part 3 to the mix. I'm excited about that. So yeah, let's jump into it. What you got for us?
Okay. Thank you very much, Peter, and thanks a lot to everybody who already joined in to part 3 of the webinar series. This time around, we are going to look into all the bounded contexts, what's happening in there. So basically, we kicked off the webinar series talking a little bit about the overview, the values, and especially the culture of DDD. And on the second installment, we went ahead and took a look at the bigger picture of domain-driven design. So we talked about the so-called strategic design, about what is a bounded context, how does DDD have a look at application landscapes, such as context maps, and so on and so forth. And today, we're going to take a deep dive into, let's say, the architecture of the internals of a bounded context. So there's, I would say, 2 different names for those things around. One is tactical design. The other one is internal building blocks. Me personally, I prefer the name internal building blocks because it comes directly to the point what those things are. They make up the internals of a given bounded context. Now, on the next installment, just a brief outlook on the webinar program. Next time we're going to talk about domain events. It's going to be all about events. What is a domain event? What is event storming? What is this event sourcing? What is CQRS? And all these things we're going to talk about in January. And please be aware that we have to push the date for the 5th installment because of the Spring Boot 2 launch. Part 5 will not be on February 15th as we have originally planned it. We're going to push it to March 29th where we talk about implementation things. Just few tiny and short words about myself. I'm Michael Plöd. I work as a principal consultant at a company called InnoQ, and I've been dealing with DDD in various projects and also from various viewpoints and aspects since back in 2006. You can follow me on Twitter. My handle is @bitboss, or you can also take a look at my GitHub profile for some example code, and I'll actually plan on pushing a few of the examples that I'm going to show off today on GitHub within this week. There's just some, let's say, cleaning up and tidying up to do for me before I want to push it to the public. Now, I'm also writing a book on domain-driven design on LeanPub. This is going to be a use case discussion of a mortgage loan application. A small part of that you'll actually see today of the use case as a more complex example on aggregates. Make sure to check it out. It's going to be published in Q1 2018. Now, I'm absolutely honest. Most of the stuff I'm going to talk about today has not been invented by me. I'm not as smart as Eric Evans or Von Vernon. So all credit is due to them for their really amazing books like the Blue Book, which has been published by Eric Evans in 2003, and the rare book, which has been published by Vaughan Vernon. And make sure to check out those really thoughtful and amazing books. Now, let me recap one thing from the strategic design chapter. Basically, strategic design is made up of bounded context, and the context map take a look how various bounded contexts interact with each other. Now, a bounded context contains a model, or may contain a model, or it should probably contain a model. And what this model is something we are exactly going to talk about today. Today we are going to look at the core domain model of a given bounded context. And the most important thing here, in terms of the bounded context, I said it last month, is the most important sentence of last month's session was the bounded context is also the boundary for the meaning of a given model. So stuff that we put in the model, it's totally okay if it's only valid within a given context. And I'm going to stress this when we talk about examples today. I will have two really big examples for you to discuss or to take a look at. And basically the model that I come up with here is only valid within those given bounded contexts. So please keep that in mind. We're not talking about a generalized, centralized model to rule them all. We're just looking at decentralized models for a given bounded context here. Now, basically the part we're going to talk about today are the internal building blocks. Now, DDD or DDD, well, discusses 6 internal building blocks: aggregates, entities, value objects, factories, repositories, and services. Some of them you may have eventually heard as Java developers who are working with Spring or JPA. So there is a Spring repository, there is a JPA entity, there is a JPA embeddable, which is probably semantically very similar to the DDD stuff. I'm not going to talk about those things from a JPA or Spring perspective today. I'm going to talk about those things from a DDD perspective today, which is very important because in my eyes, this is in terms of, I would say, the DDD adoption, things, especially Java teams, sometimes get a little bit wrong or are mixing up various concerns here, and this is something I'm going to stress out today. Now, today I will mostly, for the most part of my webinar, discuss the very interesting parts, which are, in my eyes, entities, value objects, and especially aggregates. Aggregates are, in my eyes, a very valuable pattern or approach to building up really maintainable and stable software these days. And I'll also talk briefly about factories, but only very briefly, and I will mention a couple of my insights on repositories and services. And in the end, we're going to put it all together and talk a little bit about hexagonal architectures. Now, let's start off with entities. Now, take a look what is written on this slide. So basically, from a DDD perspective, an entity represents a core business object of a given bounded context model. So those are very important things in a given model, just to be blunt. Very important stuff. Now, there's two more characteristics. I mean, very important is, I would say, a rather weak description. It's very tangible. But there's two more criteria. An entity has a constant identity. So it has an identity that remains constant over a very long span of time. And an entity has its own life cycle. Now, if you take a look at those things, and if you take a look at the JPA specification, if you put this description of an entity from the DDD books and the description of the @javax persistence.entity next to each other, you find quite a few similarities. Obviously, one author has been very inspired by the other author. One could get that impression, because what does an entity in the JPA spec have to be? It has to have annotated with an @ID annotation or with an ID XML kind of thing. And it has its own lifecycle. So the JPA entity manager only interacts with the entity, not with the embeddable. Now, do those things have something in common? No. No, no, no. Your JPA entity is not your DDD entity. This is a very important thing, and especially, I mean, of course, if you're writing really simple CRUD-style data applications, it will be a total over-engineering to mix those concerns up or to separate those concerns. But if you write, let's say, very complex, business-driven applications with a lot of business logic and a lot of processing, you should really think about separating those concerns. Your DDD entity is an entity which contains a lot of business logic. Basically, this is, in my eyes, a going back to the roots of object-oriented programming in a way. So I will mention that later on. This typical approach for POJOs, let's have private attributes, and our favorite shortcut in the IDE is generate getters and setters, and we are basically implementing all the logic in services. Is basically not the approach that DDD wants us or recommends us to follow. I will get back on that point later on. So the DDD entity contains business logic, and business logic is the core focus of the DDD entity, not persistence constraints. Now, let's step one thing further. Let's talk about the value objects. Now, the value objects do not have, in this sense, a constant identifier. Basically, the identity of a business object is being derived from its attributes. So let's say a cup of coffee costs €5. So those €5 are let's say a monetary amount. And then in this case, the monetary amount, €5, we just care about the amount 5 and the currency, euros. €5, $20, whatever. Now, we just care about the combination of both. We don't care about specific €5 in this case. Now, let's say I owe Peter $50. He bought some stuff for me in San Francisco and sent it over to me, to Europe. I owe him €50. So I could pay him those $50 through PayPal, through a bank transfer, I could pay him at the next Spring One conference next year in cash or whatever. Now, we're not talking about specific €50. Now, let's step a little bit further in time. Peter and me, we meet at the next Spring One conference, and I hand him over, I give him €50, and I have a €50 bill in my hands. Now, take a look at that bill. Now, we can have a couple of different views on this bill. We can have just the value, 50 euros. Now, this is a typical value object. Look at this 50 euro bill. It's just 50 euros. And the 50 euros themselves, they don't have their own life cycle. They just remain there, or depending on an entity that's referencing them, if the life cycle is dependent. Now, obviously, I think some of you may have found a bug on my slides. So take a look at the customer. The customer is present on the entity slide, and it is also present on the value object slide. Now, did I make a mistake when I was designing those slides? No. Let's take a look at the question. Is the customer now an entity or a value object? The answer to that is it highly depends about the bounded context I'm looking at the things. Now, a good example for that is in terms of the customer. If I have a bounded context and I'm building a microservice, I'm implementing that bounded context as a microservice. Now, one way to look at this is if it's a CRM-like microservice, which is, let's say, where the customer is really at the center of the business attention, then the customer is obviously an entity. No discussion about that. But now let's take a switch to a different context. Let's take a look at a logistics provider, a very simple shop, nothing sophisticated, nothing in UPS or whatever scale, just a very simple thing. Somebody picks up a parcel and drives it to a different location. And now the customer information, let's say this first name, last name combination, which is written on the parcel, is this an entity? I highly doubt that. I think that the main driver for those folks is the address, because that's what they are stepping up, building up the routing upon, how they load their trucks and stuff like that. And the only thing that they care about the customer is when the person who's shipping the parcel, which doorbell she's supposed to ring. Let's say you have a house with a couple of condos or something like that. There's 10 parties living in there. Now, which doorbell am I supposed to ring? Now, in this case, the customer turns from an entity in one context to a value object in another context. Let me give you another example on that one. Let's step back to Peter buying me swag in San Francisco and handing me the stuff, and I owe him 50 euros at the next Spring One conference. Now, I come to the Spring One conference with my 50 euro bill. Thank you, Peter, for purchasing some nice stuff for me in San Francisco. Let's say some special coffee roast or something. Here's your 50 euros, and I have a 50 euro bill in my hand. Now, in this context, the 50 euros are obviously a value object. But let's switch the context to the so-called Bundesdruckerei. Since I'm from Germany, I only have the German word. The Bundesdruckerei is the facility, the plant, that is actually printing those euro bills in Germany. And now, their view on those 50 euros are this very specific 50 euro bill with the idea, I'm holding a 10 euro bill right now in my hand, with the idea of XA00788 and so on and so on. So now, this 10 or this 50 euro bill becomes an entity in that context because it has its own identifier. It has its own life cycle. Now, just imagine the case that I'm unfortunately dropping the 50 euro bill on the floor, and one of my pug dogs, who are obviously extremely hungry, eats it. The 50 euro bill is gone. It has its own life cycle. So this specific 50 euro bill is gone. It's in the stomach of the pug. And he's a bit disappointed that it was just a piece of paper and not some proper food. But obviously, in this case, when I look at the Bundesdruckerei, the printing facility, this bill is an entity because of the life cycle approach. Now, both rules obviously also totally apply to the JPA world of things. Like the JPA has embeddables, which is an equivalent to the value object, and entities, which are an equivalent to the DDD entity. But there is a difference. Never ever let in more sophisticated applications persistence, thoughts, and constraint drive your decision for an entity or a value object. There is one thing in the JPA spec, for instance, that you can't nest collections of elements. So in nested trees of collections of elements, there needs to be something that can actually be an embeddable, must become an entity in order for a lot of JPA specifications, implementations to work. Now, this is something you really do not want to have, that a persistence library or specification is your driver for a decision between do I implement that as an entity or a value object. It should always and always, without any exception, be business constraints that drive those things. Now, the next step or the next thing is the aggregate. In my eyes, the aggregate is next to the idea of a bounded context, one of the gems in domain-driven design. There is one quote which I often refer to from the microservices community, which is structure your microservices or your self-contained systems along bounded context. And this is totally true. I have no doubt about that. And which makes the bounded context a very prominent thing in DDD in 2017, obviously with the whole trend around microservices. But one thing that I see a lot of teams struggling with is, do I go for a small and a very fine-grained bounded context in order to, but then I think that would be something, or they think, hey, this would be good, but then we have to deal with a lot of very fine-grained deployment units, and this extremely fine-grained stuff doesn't fit, let's say, into our delivery culture and whatever, and we're unsure about that. And this is where I often bring in the idea of the aggregate. The aggregate is another, I would say, logical boundary, a logical bracket around entities and value objects. And basically what it is, it groups entities and value objects together. And yes, of course, we don't need to call this aggregate as it is, because, well, let's just make different object graphs and let's put some lines around certain object graphs. True, but the aggregate delivers a couple of more things. One of those things is the so-called root entity. If you look at this slide that you currently see, you see this lone application form, which is the root entity. And this is, I would say, a special thing in terms of the aggregate. The nice thing about the root entity is, rule one is, it controls the life cycle of the complete aggregate. So if you delete the root entity, you remove all the stuff below it. Yes, this is a very special entity because it can overrule the life cycle of other entities in the aggregate. True. And the other thing that I consider to be very valuable is the thing that the root entity acts as the single access point into an aggregate. So basically from the outside, I couldn't reference to the customer entity. in this case. But there is, I would say, there is a little bit of a discussion if you want to go ahead and make, let's say, coarse-grained or, let's say, fine-grained examples. Let me show you a different. Let me show you a different take on this scenario with more fine-grained examples. Now I made two aggregates from this. So basically, I encapsulated the loan application form and the customer into two aggregates. And let's say the customer is, to be honest, a rather boring aggregate. It's just one entity and a value object. But there are quite a few other aspects that come into this. So far, I've mostly, I would say, discussed the Eric Evans school of aggregates. Let me add some of the insights from the Vaughan Vernon books to this. One of those is, take a look at the reference between the loan application form to the customer. Now, one option that we could, in a way that we could implement that, is that we say, loan application form get customer, and we receive the full customer. That's one way of doing things. A suggestion that has been heavily brought up by Vaughan and that I absolutely second is, don't do that. Rather go ahead and say loan application form get customer number. So we introduce a, let's say, a tight wall behind that. So no more endless object graph navigation here. So clear boundaries around the aggregates. So if I need to get to the customer, if I really need the customer aggregate, I have to obtain it from a repository. We'll talk about repositories later on. And this is, in my eyes, a very valuable thing as well. And I think small aggregates are easier to maintain. They are easier to unit test. They are easier to extend. So I really prefer this one entity and a couple of value objects approach very much. This is also something that I see in a couple of code or architecture reviews on a quite regular basis. Excuse me. I see too many entities, to be honest. I see way too many entities. I actually prefer seeing, I mean, it always depends. I think it depends is the best standard answer for any software architect out there. But I think it strongly depends on the background, but I prefer seeing something like, let's say, 15 to 30% entities, and the rest should be value objects, because there's such an easier semantic that comes with this way of implementing things. Now, there are a couple of other hints that you can and should consider when you think about aggregates, the best practices. One, prefer small aggregates. I already dwelled into that. The next is, please make the reference by the identity, not by the object directly. It makes things so much more stable. So typical thing that happens very often if you fail on this best practice is, oh, I fixed something over there and suddenly at a total different place a new bug pops up. Because why can this happen? Take a look at a ship. If you build a big ship and one chamber in the bottom of the ship runs on a rock, it runs full. Now, if you have good bulkheads under, the resilience community is also often referring to this pattern from shipbuilding bulkheads. If you don't have bulkheads, your ship runs full and sinks. If you introduce bulkheads, and this reference by identity is for me an object graph navigation bulkhead, you just isolate things together. Now, the next two best practices are actually quite interesting. One aggregate, updates to one aggregate should be encapsulated in one transaction, and the other one is see aggregates also as consistency boundaries. Now, especially the last two have also been heavily discussed in Vaughan's Red Book and the DDD distilled book by him. And the more I think about it, the more I actually agree with those rules. Now, you might think, if I follow those rules, why do I still put them in the same context and eventually have them in the same microservice? Well, I think if you follow those rules, you can build really stable and maintainable and robust, let's say, coarse-grained structures. I'm especially not saying you can build great monoliths with that, because the name monolith is now a little bit, well, let's say, under a bad weather right now, but actually I think mostly because of most of the badly developed ball of mud style monoliths out there. But in my eyes, you can, if you follow those rules, you can build up a structure that is more coarse-grained in the first place, which is very stable, very maintainable, very robust, but you have an easy time pulling out things from that structure if you follow those aggregate rules. It's really easy because, first of all, you have the object graph navigation bulkhead in terms of the identity thing. So you don't need to address every sort of object graph navigation that you have in the first place. And after that, you encapsulate the consistency in one transaction. And so you don't have to, when you pull out stuff from this bounded context and move it to another bounded context because it's growing and growing and growing, getting bigger and bigger, you suddenly go ahead and realize, okay, I can easily pull that out into its own bounded context because suddenly this aggregate grows and it justifies to be another bounded context. So you can create a really model that is, you can have an evolution on, an evolutionary model, which is a really nice thing to do. And so in my eyes, this is something you should take a very close look. And I brought two bigger examples for you to discuss in terms of aggregates. Now, before I go to the example, let me go to another slide about breaking the rules. Those are, I would say, a couple of pretty tough rules. I totally agree with that. And please be aware that I do not want to come along as to either you follow the rules or you totally fail. I mean, the world is not black and white. The world consists of shades of gray coupled with a ton of colors. And this is especially valid here. Think what is the best solution for you. And my approach to that is I try to follow by the rules. I really try to fulfill them. But sometimes performance, transactions, UI convenience, infrastructure constraints can always be driver for breaking the rules. What I just say is if you break some of those ideas and rules, just know what you're doing and why you are doing those things, and document why you are breaking the rules in a given case. And that's absolutely okay. It shouldn't just be easy to break the rules. As soon as it's easy to break those rules, everybody breaks them, and you end up with a mess. Make it a little bit inconvenient to break the rules in your software architecture. Now, let's take a look at a couple of examples. The first example for you that I have is the battery of an electric car. Now, this Creative Commons picture on that slide shows a rough sketch of an electric car. I think it is, as far as I know, the battery pack of the BMW i3, but I'm not sure. Now, what we see there is those big white boxes in the middle of the image are actually battery cells. Every sophisticated battery of an electric car isn't just one huge cell. It consists of a number of cells. Now, here we have, I would say, rather big cells. If you take a look at the battery of a Tesla, for instance, you will find hundreds and thousands of really small cells. Now, they make up cell blocks, and the cell blocks make up the whole battery. Then, in the front of the image, we see a charger. So every battery has I would say, a rather sophisticated charging facility for itself. Now, it's a bad practice, for instance, to overcharge cells. It's not good to charge the car every time to 100% and stuff like that. And eventually, some of you drive an electric car, so they know that. If you don't, heed my warnings. Don't charge it to 100% all the time if you want to maintain a good health on the battery. Now, this is a very internal view that we have here on this image. Is this the way that us as consumers interact with the battery? Probably not. Now, let's dwell a bit deeper into this example. And think about the practice of information hiding as well from the aggregates perspective. Unfortunately, so in good programming practice, there is a principle called information hiding. And we can implement this principle with the visibility operators that our programming languages deliver us. So since I'm a Java guy, and I assume since it's a Spring Pivotal webinar, most of you are programming with Java, we know that we have private, package protected, protected, and public as visibility operators on a method level, on an attribute level, and we also have a visibility operator on a class level. So, but unfortunately, what I see in most of the Java code written nowadays is that this has diminished to a certain degree. What do? We go ahead and create a Java class, put private variables in this, and then our favorite shortcut is generate getter and setter. And basically, and those getters and setters usually do have a, let's say, a public visibility. With this programming model, we're basically undermining information hiding. This is no information hiding in my eyes. Now, we can put this idea to work with the aggregate. Now, just imagine putting your aggregate into one package, and you work very, very much with package visibility and public and eventually private as a visibility. I have a question to you folks. Do you see any slides right now? If you can give me a feedback, because the slides have blacked out on my screen. If you could just send me a yes or a no in the questions from the audience section or something like that. They just came back to me. I just want to make sure that you see the slide. Now, let me go a little bit further. But in this example, do we really need an access from an external actor to every battery cell? Do we, as drivers of an electric car, really care about the semantic of a cell? No, we don't. What we care about is we want to start charging. If we plug in a cable, we want to know how much is the battery's. Thanks, I just got the feedback in a couple of yeses. Thank you very much. I see them right now as well. Now, what we want to see is the charge level. We want to set the charge level. We want to start charging, and we want to stop charging. Do we really open our battery case and see, this cell is 50% charged, this cell is 80% charged? Do we care about that? No. And this is also a semantic you can apply when you implement aggregates a lot. This graphic here is, let's say, a public view, a view of all internals of such an aggregate. If you make it full screen, you can probably read what's there. I, as a presenter, only have a tiny thing. Now, this is a way that I like to implement aggregates a lot. I work with a dedicated aggregate class, for instance, and I place the root entity below that class, so the aggregate class is referencing the root entity. And beyond that, but I am hiding a lot of stuff, behind the actual aggregate class, because I work very, very much with package visibility. I do not want outside actors to have any insights to certain value objects that I have, to certain entities that I have in there. So there is a dedicated external interaction point on the aggregate. Now, let me step a little bit further. This is now the view on all visibility operators. Now, the next view is basically this, what is publicly visible from this aggregate implementation here. So obviously we have the battery aggregate. We have some battery information like the ID and its capacity that we, for instance, have. And we have a battery status and a couple of, let's say, methods to interact with the aggregate. We start charging, we stop charging. But as you can see, like a lot of the internal stuff, like the root entity, the cell charger, the cell blocks, and the cells are hidden. They are not visible from the outside. And in my eyes, this is a very interesting approach to implementing aggregates. On the fifth part of our series, when we talk about coding and so on, we will take a coding deep dive into those structures as well. Now, let me step to a more complex example. Let's think about a loan application. Now, this pug dog owns a bank, and so you can apply for a loan at his bank. So we can enter some terms, an amount, and a purpose for a loan. We enter some, let's say, financial information, how much we earn, how much we have to spend on rent or cost of living or other loans and stuff like that. And we enter some personal data. And this personal data is something that us as a bank are interested in. But we also use this personal data to go to an external credit agency and ask for a rating on the given customer's creditworthiness. So for instance, in Germany, we have the Schufa, where we can, as a bank, go to them and tell them, hey, I have a Michael Plöd living in Kreuzstraße 16 in 8331 Munich, which is our InnoQ office. I don't live in Munich. And how is his creditworthiness? And this agency collects creditworthiness information from insurance companies, telecom providers, other banks, and so on, and calculates a, let's say, a value, how high the probability is that I am able to pay back a given loan. Now, they also deliver usually a couple of other messages, like warnings. Hey, this customer failed to pay on an invoice, or a negative message. Hey, this customer is currently in a private insolvency process or something like that. Now, every banking application that shells out loans has a scoring process where we are calculating an internal score for this loan application if we want to grant this. Now, what I have here is a model, a UML diagram, and I'll also suggest a full screen mode on that, which implements basically 4 aggregates and puts them into, let's say, into context. And what you can see here is that there are, I would say, a public of public information where we can build up a person ID, an application number, and then we have, for instance, an agency, an applicant, and financial situation, and a percentage calculation aggregate here. Now, I will switch you quickly, because I don't want to annoy you with too much UML stuff, to a screen sharing. Let's see if that works. It's the first time for me on the platform. I need to start it. Turned off before I started the presentation. So yes, my whole screen is what I want to share, and now you should see the screen share over there. Now, I have thank you. So I have prepared both of the examples, the electric car battery and the scoring stuff as an aggregate example project. I'll tidy that up and put it on GitHub as well, so you have a reference. So I implemented a couple of aggregates over there, and let me start with the calculation one. So basically what you can see here is that I put a lot of stuff into one package here. So, and I have a service here that is taking in a couple of aggregates, let's say an application number, an agency result, applicant, and so on. And I can now interact with those aggregates. So I can calculate scoring points on this one, agency result. I can see if there is a no-go criteria in the agency result, an applicant aggregate, a financial situation aggregate. And then I put this information. Those aggregates just give me a couple of points back. Hey, the person is getting 20 points on the financial situation and so on. And I calculate that together, and I put them into a new scoring result aggregate. And what you see here is I like working with the builder pattern a lot. I ramp up a new aggregate with the builder pattern, basically. And the interesting thing is, from the outside, I can't integrate. I can't work a lot with, for instance, the agency result aggregate. So let's go to the agency result aggregate, and its public interface is acceptable or calculate scoring points. Now, let me go ahead and ramp up a new agency result aggregate. So I go agency result aggregate, builder, and I need to ramp this up with a special constructor over there. This takes in points, so let's say 20 points, and I can add for a person. For person, Michael, Plöd, Kreuz, 16 in 8331 Munich, for instance. I can add, the next thing is, let's add a KO criteria, no KO criteria there, but with a warning. Let's say the key is 100, customer or didn't pay his beer at the bar, for instance. In Germany, that's called a Zerstreller, person who doesn't pay their bill at the bar and just leaves. It's a capital crime in Bavaria. And then we just build it. So now if I get a new agency result aggregate, and now with this, I can just get if it's acceptable, and I get the overall scoring points for that. I do not have any view on the internals of the aggregate, but let's take a look at it on the internals. So it has a root entity. We have the builder implementation on it, and the root entity has a person ID, it has points, KO criteria, warning messages, and so on. And you see I work a lot with package visibility. on the implementations. Now, stepping back to my slides here, you see I have a couple of things here, for instance, for the agency result. On the left-hand side is the public view of the agency result. Right-hand side, the internal view of it. The same goes out to the applicant, to the person's thing. So left-hand side, very tight way or very small footprint on which you can couple your code against the aggregate. On the right-hand side, the internal view. And I always keep saying that loose coupling starts at the provider's place. If you as a provider open your door to loose coupling, your consumers will loosely couple against you. Now, and this doesn't open many doors because in this case, for instance, no one from the external way can interact or set up any rules on the accounts balance on the applicant aggregate because it's not their business. It's just the internal of the aggregate, how I work with information hiding here. And the same goes now to the calculation part, but I've shown you a couple of things on that. Now, please be aware, part 5 of the webinar series will be a deep dive on a coding level into those things. And obviously, we also talk about factories or builder pattern, what I've shown you in order to ramp up object class. Repository are an interesting thing. Now, obviously, a lot of you know about the Spring Data repository. Basically, yes, this is the data access, but in my personal opinion, the DDD repository is a little bit more than just the data access layer. In my eyes, your JPA entities, your JPA embeddables, your entity manager code, your Spring Data repositories are part of the DDD repository. I have a, let's say, a broader view on this thing. And then we have the services. The services, in this case, only implement orchestration logic. This is something that you've seen in my very first code example, this calculation service. Just put in a couple of aggregates, orchestrate it amongst them. I didn't add any repository stuff, and it just had orchestration logic, no business logic. The business logic resides in the aggregates. This is very important here. And you can put all of this stuff into context with an architecture pattern called hexagonal architecture. This is not only in the DDD community now a very favorite approach, also other software architecture community discuss those things. So basically we talk about an input world and an output world, and now taking a look at a bigger picture on this. We have like an input adapter that's consuming requests. Those are your REST controllers, your message listeners, for instance, some SOAP endpoints or something. And they implement a specific, let's say, I call it protocol technology. Then we have the application services. Those are the services that are orchestrating over various aggregates or with the core domain model. And the core domain model is basically your aggregates, your entities, your value objects, and so on. And then we go to output adapters that were, for instance, the repositories are located at, where we store stuff to a database, where we publish messages, for instance, with Spring Cloud, Stream, or stuff like that. And we will put all of those things to work in a Spring Boot microservice on this use case, on the banking use case. In the 5th installment of the webinar, we will implement this sort of architecture with everything, like with the repositories, entities, value objects, aggregates, and so on and so forth. Now, that's it from my side on the technical design part, on the internal building blocks. I hope I was able to give you a couple of new insights on those things. If you have questions, just type them in. So far, there are right now no questions yet. We have a couple of minutes left for questions to come in. The next part will be about domain events. So we think about those aggregates and what sort of events they can publish, how we can work with event-based applications. This will take place January 17th. And this date is fixed. We will push the part 5 to March 29th in order to make room on the slot on the 15th for the Spring Boot 2 stuff, which is probably pretty awesome. And so, yeah, that's the webinar series. So far, I would like to say thank you very much for listening to me. You can contact me on Twitter @BitBoss, check out my book on LeanPub, and yeah, let me hand over to Peter for the time being.
Yep, thanks, Michael. So yeah, if you folks, if you have questions for Michael, now is a great time to enter those questions into the Q&A panel of your user interface on BrightTalk. In the meantime, also, why don't you also look through the attachments and links section. As you can watch replays, you can find links for some of the replays for some of the earlier installments of this series from Michael, as well as if you're interested in his book, there's a link there that you can indicate your interest. In fact, it seems like someone from the webinar, Michael, has already given you a 5-star rating and saying they're very interested in buying the book, which is fantastic.
Thank you very much. I already saw it and highly appreciated it.
Yep. Yeah, so now would be a great time to enter in those questions. If you want to follow Michael on Twitter, he's available to be followed at BitBoss. And I can say that you have an excellent stream of content, not just on domain-driven design, but all kinds of good stuff. Particularly music, I've noticed. Michael is excellent.
Heavy rock music and domain-driven design.
That's right. That's right. Just an absolutely fantastic combination, especially with coffee. So, folks, yeah, as you heard Michael say, we are continuing this series. We're going to be doing the next installments as you can see on the slide, and then we're also going to be doing a Spring Boot 2.0 launch, we believe, in late February. So stay tuned for announcements on that. And Michael, was there, I don't think so, but was there any GitHub repositories for what you were showing today, or no?
There will be, not yet. I will probably publish or push the code example tomorrow, no later than Thursday on GitHub, github.com/mplod.
Very good. Okay, well, we can attach that link to the replay, so that's no problem. All right, folks. Well, if there aren't any questions, we can wrap it up on time for the day. We'll give it another moment or two to see if there's anything. In the meantime, I just want to let folks know that we just wrapped up Spring 1, and you'll be able to consume a lot of the videos if you go to the Pivotal channel, YouTube channel, or the Spring YouTube channel a little bit later this week, probably tomorrow, maybe at the latest Thursday. You'll see the videos that are from the conference should be up. We're still kind of pulling together slides and everything from the various presenters, but we should have most of those. And they'll be available for you on YouTube. The easiest way you can go find all this stuff is just to look at the Spring 1 platform website. It'll be the aggregation point for all of it, so that you don't have to go chasing down playlists and such. So if you're curious, check that out. Now, you did have one question come in, Michael, on, is the Vernon definition of aggregate, in the Vernon definition, an aggregate is a unit of composition that's defined by transactional consistency. Would you comment on that?
Yeah, basically, I fully agree with that. Yes, it is in my eyes as well. That's basically what I meant with one of the best practices on an aggregate is also on consistency boundary. Yes, yes, please. Try to follow that idea, and yeah.
Excellent. All right. I think that's it for the moment. Yeah, and actually, we had Vernon speaking at Spring 1 platform, and he's offered to do a workshop for us next year. So we might already have our first accepted session at Spring 1 next year. he mentioned that he's actually worked with you a little bit, Michael, so that sounds cool. All right, well, if there's nothing else, please take a moment to give Michael some feedback. If you go down to the feedback, maybe give him a little bit of you can just give him a simple rating and any text feedback you like. That's always helpful so our presenters can get better. And don't forget to go to the attachments and links section so that you can bookmark anything you want. And then, of course, as always, if you want to give us some guidance on topics you'd like to hear about in the future, you can do that over there in the polls section. And I think that's it. Michael, anything you want to say before we call it a wrap today?
No, actually not.
Okay.
Thanks everyone for attending.
Thanks for your time, everyone.
And
have a
have a great rest of the day.